Hello physics lovers, welcome to my Genius Physics classroom and welcome to Genius Physics with Shamila program as well. Guys, I'm today here with a brand new topic which has not been discussed since the beginning of this YouTube channel. Not only the channel here, my physics program as well. So the topic is how objects move along circular paths, right? Yes. So this is not very similar to the linear motion, guys. It's simply it's a circular motion. So I'm going to discuss about circular motion today, and it is something really strange. Why is that? Wait for a moment. I'm going to explain everything. Before move on to the topic, guys, here one of my exercise objects or exercise equipments. You can use it if you want. I'm not going to recommend any place that you can buy these sort of things, right? By the way, if you want, you can buy, right? So I'm going to, and this is some sort of holidays here, and so when we practicing or when we practice those exercises or when we work out, so we can yeah, hold this one, and this is kind of a holder here, right? So what I'm going to do is I'm going to, yeah, so you can see that. So now can you see this holder is moving along a circular path, right? Moving along a circular path, and meantime you might be able to observe, right? You might be able to observe the tension of this, this some sort of plastic strings, right? The tension of these strings also can be observed if you carefully observe this one here. Why is that? What is the use of that tension? Interesting, right? Isn't it interesting? For me, it's interesting, right? Listen to me carefully. So, guys, now what do you think about, even though the speed of this motion, or this is my object here, yeah, so I try my best to illustrate the motion of this one here, right? So if this is your holder or this is the object, and imagine for a moment when the speed of this one, the speed of this object is constant. Speed of this object is constant doesn't mean the velocity of that one is constant. Why is that? We all know that, guys. The velocity is a vector. It is not a scalar quantity, which means the direction and the magnitude of both of those things matters. Both of those things must be considered. That's the thing here, right? Even though the magnitude of this velocity constant when you maintain a constant speed, the direction is not constant during its motion, guys. Why is that? So all the time, if you carefully observe, all the time its direction is changing like that here. So instantaneous changes we can observe, which means when the velocity changes according to Newton's second law, as we all know that, according to Newton's second law, we can say that as velocity changes, acceleration, some sort of acceleration must be exerted upon this one in order to change the velocity of this. Wow, amazing, right? But we can't. So when you use basic mathematics, yeah. So what I'm going to explain this one is today using those basic mathematical theories. I'm not going to use advanced theories. I don't want to use. But when you use vector formulas or vector theories, you can easily describe this one's motion and the direction of acceleration. But I'm going to use all of those physics lovers are not mathematicians. Therefore, I'm not going to use the hard mathematical concepts. I'm not going to use here, right? So instead of that, I'm going to use very simple mathematical phenomena or mathematical theory which is behind this. Look at this carefully. What I'm going to analyze here, first of all, let's consider the change of velocity, right? I'm going to consider two different positions of this motion here, right? So capital A and capital B positions, these two different positions of this motion, right? So let's consider the velocity, right? The velocity change we can understand if you carefully observe, right? There is another way we have to resolve these two velocities along same two directions, otherwise we won't be able to analyze it. So I'm going to do that thing, otherwise we can't do anything here, right? Look at this. The capital A, when you resolve, and this is my final most position here, change in, not the momentum, we have made a mistake, slight mistake, change in velocity, if you carefully observe, right? A change in velocity in the direction or vertical direction when you analyze, the vertical towards upward direction I consider here. So here delta V, you can identify here V cos theta. Why is that? Right, this is my final velocity when you resolve it towards that direction and this direction. Right, the vertical factor is, the vertical component is V cos theta minus, right, so this one, final one, same direction component. Take a look at this component and try to pay your attention on the component of this one, V cos theta, the minus V cos theta, right? So equals 0. No effect. Wait. Then come up to the second case, change in momentum. Wait, wrong. Velocity in that direction. That means a horizontal and right side. Oh, not right. This direction. Let's consider left side here. Alright, delta V, change in velocity. Look at it. This one's horizontal component is headed towards that direction, left side. V sine theta minus, right? This one opposite directed, minus V sine theta, right? So all together we can say the minus times minus plus. Then now when you add these two, it becomes automatically becomes what? 2V sine theta, right? Okay, now there is a change in velocity. Good, good, good. Right. Now we need time. Another hero. So we can't discuss anything regarding or relevant to acceleration except time factor. Right. Let's take this time. If time is taken, right, if the time is taken to move from capital A to B, I'm going to consider it as simple t here. Right, so then now you will be able to explain not the force here, acceleration, right? How? The delta V over t. What is it? Change in velocity over time, right? The rate of change of velocity is simply what? Acceleration, right? Okay, now here is 2V sine theta over t, right? I'm going to take this equation as 1. Let's keep it as it is. Move on to the next case. Distance from A to B, right? So all of you, simple mathematics. So we can use simple mathematics to analyze the distance from capital A to B. That is the arc length, right? We all know that these angles are measured in radians. When you use radians or when radians are utilized, you can simply describe the arc length using this method. What is that? The distance from capital A to B is 2 theta, which means this entire angle times r. Okay, fine. Right, so then tangential, what is the tangential? What the heck? What is that word? No worries. Now, tangential means here, this is a constant. Even, yeah, we know that here speed is constant speed, or you can say it is instantaneous speed here, because the speed doesn't change. Yeah, we can accelerate it if there is an angular acceleration, but here I'm just analyzing an object which has got a, or which moves at constant angular velocity, right? So therefore the tangential or the instantaneous velocity remains unchanged, right? Okay, let's take it as it is. Then velocity is the velocity, or this is tangential, the instantaneous or tangential velocity can be described as v is equal to theta over t. Yeah, we know that the path is not linear. Even though the path is not linear here, simply the speed factor I consider. That's the reason here the v is equal to theta r over t, right? So then simply you can say, but here the hero is not the v. So my hero is t. Right, since my hero is t here, I'm going to make it subject. Which factor? T, I'm going to make it subject, right? Let's take it on the hand side. Right, then t is equal to theta o r over v here, r, No confusions, the r is radius, right? So let's substitute. I'm going to substitute this t time in this, not the force, acceleration equation. Here also acceleration, right? In the equation number 1 here, then 2v sine theta over 2 theta r over v. What is that? Time here, right? So now we can see some sort of complicated equation. It is a is equal v squared over r sine theta over theta. Is it complicated? I don't think so. Not that much, right? Pay your attention, guys. But here, I just need to analyze it for every moment, for instant moment, for the next instant here, for all the instances. I need to analyze the acceleration at every instant. That's what I'm going to do here, which means this theta here, limits, the mathematical limits I'm going to use here. We can use mathematical limits, right? How? The instant changes means instant time varies, or instant time intervals. During instant time intervals, this theta is almost 0. So therefore, I'm going to use limits, and I'm going to apply limits here. Limits. The theta goes to 0, or when the theta, it was almost 0, just try to understand here, right? So here, not f here, a, acceleration is limit theta goes to v squared over r sine theta over theta. Something interesting is on the way. Look at this. Then v squared, the same limit, so v squared over r, but limits here theta goes to infinity sine theta. This is the most interesting part. Yeah, the people who learn for the mathematics or the algebra part or the trigonometry, they know when the limits goes to infinity or theta goes to infinity, sine theta over theta part becomes 1 here, right? So it is not something upset, or it's not something annoying anymore. It's not an annoying thing here. Why is that? It's going to be 1, right? So then f, not f here, a, the acceleration is, we can say v squared over r. And the other thing is, the v can be written as, we all know here, v factor. We all know the tangential speed, or vt, or let's take it as v is equal to r omega. So I'm going to use this one. And when you substitute that factor here, r omega squared and v squared over r, or r omega squared, the direction is always perpendicular to the direction of velocity at any given instant, right? This is it, guys. So this acceleration is called as, there is a very interesting, and we have heard it before. I think you, so all the physicists must have heard this name. What is it? Centripetal acceleration, right? The word is centripetal acceleration, right? And the next thing is what here? We have three things actually. You can use either v squared over r, or r omega squared, or v omega. Any of those things are correct. Similar equations. And finally, when there is an acceleration occurs, or acceleration takes place, the acceleration is followed by whom? Force. Never forget the force here. Then you can describe the force. The centripetal acceleration is AR, so then you can say the force or centripetal acceleration FR is what? The MAR, and the mass is, MAR. When the mass of the object is M here, MAR can be expressed, and that is what? The centripetal acceleration, which means the final conclusion is, in order to move any of those things, you, me, any object, you, or everything in this universe, when it, or any sort of object, if any sort of object needs to move along a circular path, kind of a force is required always along the radius towards the center. What is that force? Force is centripetal force. That's why we can easily observe when this object moves, when this is moving in this circular path, right? the tension is exerted towards along this radius towards the center. That's it. Keep in touch. Hope to see you soon with another amazing topic. Thank you guys.